Come back to max learning groups. Now today we are going to look at another kind of speed problem, but I think it's the same problem that we have gone through already the last several lessons, but the way that we solve it is a bit different. So in our last lesson we talked about how to draw the model, and then we use the model to solve it. So that is the method that we will be using again, but there's one extra thing that we are going to talk about. So when it comes to questions that are a bit harder, and you find that you are stuck after you draw the model and you're still stuck because you don't know how to fill in the blanks, then how do we carry on from there? So I'm going to show you this particular problem, like how we're going to continue from there. After you draw the model and then you find that you don't know how to do, so there's a way to continue doing. Alright, so let's look at this way. So if you look at this question, which I will show you now, the distance between point A and point B is 48 kilometers. Right, so I'm going to highlight. So when you read your question, you highlight the keywords. Right, the distance between the 2 points is 48 kilometers. And what's going to happen is this: Kenny runs from A to B, right, at a speed of 11 kilometers per hour. So there's one person running from A to B, and his speed is 11 km per hour. So like what I mentioned, the word average is not your, what does it mean? The word average means it's constant speed, right? The speed never changes. But you don't have to actually look at this word. You can just read it like Kenny runs from A to B at a speed of 11 km per hour. That'll be more relevant, okay, more easier to understand. At the same time, Mary runs from B to A at the speed of 5 km per hour. So Mary is running from the opposite direction. So you will need to know how they move by acting out with your fingers. So how far, which is the distance, will each of them have run when they meet on the way? So if you were to use your fingers to act out, how does it actually look like? It will look like this, right? So you have two fingers to represent two person. So you have Kenny from A to B, and then you have Mary from B to A. So they are going to run towards each other and they are going to meet. Alright, some of you like to do this, which is nothing wrong. So they can move towards each other and they bang each other. So there's an accident. Alright, or like what I show other students, you can also draw this way. So they move towards each other and they were like passing by. Alright, it's something like passing by. Alright, so that's how you draw the model when they meet each other. Do you continue to draw like this? No, because the question never says that after meeting then they continue to travel. So the question never say that. So when you draw out the motion, it should be something like this, meeting, or it should be something like this, meeting. Okay, meeting. Alright, so you have two ways of drawing. You just have to choose whichever way you like. So we're going to come back to the model and see how we draw that. So if you go back to the question, so we are going to draw the model now, and so we have A to B. So there is a distant line from point A to point B, and there's a dotted line to show where Kenny starts, and then you have dotted line to show where Mary starts, and they both travel towards each other. And who is faster? If Kenny is faster, then he will travel a longer distance. Mary is slower, there will be a shorter distance, and that's the dotted line. Alright, dotted line to show where they start and where they meet. And at the beginning of the speed lesson, we have learned that every part of the journey has a family. Right, you have a speed, distance, time in the same family. Then Mary has one part journey, which is also the speed, distance, and time, which is another part, right? So another family. So you can see that every part of the journey there is a family of speed, distance, and time. All right, once you have done the model, which is like this, then the next step is to fill in the numbers. So the distance between the 2 points is 48 km, and the Kenny's speed is 11 km per hour. And Mary's speed is 5 km per hour. So how far will each of them have run, which is the distance, right, that you're supposed to find? And the model is done already, and you realize that you still can't solve it. But in our earlier lesson, we have looked at this question before, exactly the same question. And what did we learn? We learned that we learned that in 1 hour they travel a total distance of how many? 11 plus 5. So they travel a total distance of 16 km. Right? But they haven't met each other yet because they are still a distance from each other. But they are nearer now, nearer to each other, because they travel 16 kilometers after 1 hour, and now they are nearer. So in order for them to meet, then they will have to travel 48 km in order for them to meet. So that will take them 3 hours, and that's where what we do. That's what we do, or what we did the last lesson, right? We can find the time taken to meet, and then we can find the distance later, right? So that's one way to solve. But today I'm not going to talk about this because we have talked about this in the last few lessons. So I'm going to talk about something else, which will help you to solve harder questions than this. So using ratio. Because why do we use ratio? Because if you look at the speed model, you find that there are many things missing, right? But you only have two speed, right? You can see that from the model, there are two kinds of speed. You have Kenny's speed and you have Mary's speed, all right? So we are using the speed, something called the speed ratio, or we create something called speed ratio. So Kenny has 11 km per hour, we call it 11 units. Mary is 5 km per hour, so her speed is 5 units. So we created speed ratio. How? Why? Because the model has the two kinds of speed given. And from the speed ratio, we will come up with the distance and also the time ratio. So what is the distance ratio? If Kenny is faster, then Kenny will take a longer will travel a longer distance because Kenny is faster, and then Mary will travel shorter distance. So the speed and the distance ratio are the same, but the time ratio is inversely proportional. What is that? It means that upside down. It means that if you are faster, you take shorter time. So therefore, Kenny time is 5 units only, right? Kenny takes shorter time to travel because his speed is faster, so he will reach earlier. And Mary take a longer time because her speed is lower, right? So the concept of speed is if you are faster, you take shorter time. And if you're slower, you take longer time. That's a concept. And sometimes if you're faster, you travel longer distance as well. And if you're slower, you travel shorter distance. That is the concept on speed. Alright, so using that, what do we do next? You can't use the speed ratio to solve because you created the speed ratio. So you can't use what you have created to solve. You will have to either use the distance or the time ratio. So which one do we use? And you look at the model and you can see, or look at the question as well in the model, there is no time duration. There's no how much longer time did Mary take than Kenny. There's no how much longer time. But what we do see is, we see there is a total distance they must travel in order to meet. So we will need to look at distance ratio. So the time ratio, we can't use that, because there's no how much longer time that we can see over here, right? We don't see any duration of time. So but what we see is the distance, and we use distance ratio. So if you look at the distance ratio, you can see that Kenny distance is 11 units, Mary is 5 units, and if you add them together, what is their total distance? Their total distance is 16 units, and isn't that the 48 kilometers that they have to travel altogether in order for them to meet each other, right? So that 48 kilometer is that total distance they must travel to meet each other, which is 16 unit. So your 1 unit will be 48 divided by 16. So you get 3 km. And then you can find the distance traveled by Kenny. Kenny traveled 11 units, which is 33 km. And that's your important answer for the first one. And then Mary's distance will be 5 unit, which is 5 times 3, which is 15 km. So Mary distance is 15 km, and whatever answer you have worked out, you put inside the model, and that's your second important value. So Kenny distance is 33 kilometer, Mary distance is 15 kilometer. So do I need to find the time taken by each person? We don't have to, because you got the answer already. So what is the lesson here? Now the lesson here is, now if you find that when do we use ratio? We use ratio when you draw the model and you find that there are many things missing, but there are two types of speed given. And so you can think about using ratio, but sometimes you don't really have to start with speed ratio. Sometimes you can even start with time ratio, right? You may have the time taken for each of them, and then the rest don't have. All the other values are not there. Then you can also start with time ratio. Sometimes you can also start with distance ratio. So it all depends on what is in the question. So the speed ratio, or the ratio that you see today, is something that is quite important, because it will help you to solve harder questions. Right? So when you look at the model and there are so many blanks, so many things missing, then you may want to consider whether can use the ratio method to work out the answer. Right? So so that's the lesson on speed, and we still have a few more lessons to finish up, and then more or less you will be able to understand roughly how to draw the model. Alright, so do watch the video, the lesson video on speed, starting from lesson 1, because lesson 1 teach you the basic on how to draw a speed model, and then lesson 2 continue to build on what you have learned, and then when you come to something a bit more complicated, you will know how to draw a good model. Alright, so see you. Alright, see you in our next coming lesson on speed. So we will continue to talk about how to break down the problem, and how to use the method effectively to work out the answer. So see you in our next lesson.